Okay, so the derivative of sine inverse of x happened to be 1 all upon square root of 1 minus x squared, which we just proved. Remember, this is our rough work. Okay, so let's continue. So we have gotten y prime, which is the first derivative of y with respect to x, but we also need to find y prime prime. That's the second derivative of y with respect to x. So we need to differentiate this y prime in order for us to have the second derivative. Now, let's do that. Okay, look at this. Let me differentiate this in our rough work. If I should, of course, our y prime prime will now be equals to, if I should bring this out, let's say we have that, okay, for instance, our y is equals to, suppose our y is equals to 1 all upon square root of 1 minus x squared. And of course, you need to know that this is the same thing as y equals to 1 all upon, from the law of indices, we are told that root a is the same thing as a to the power 1 all upon 2. You should know that from the laws of indices. Therefore, this will now be 1 minus x squared all raised to the power 1 over 2. Having this in mind, also from the law of indices, we are told that 1 all upon a is the same thing as a to the power minus 1. Therefore, we now have this to be that y is equals to 1 minus x squared all raised to the power minus 1 over 2. That's the inverse law. When you apply inverse law, you have that. Now, we want to differentiate y with respect to x. And of course, here we apply chain rule. Applying chain rule, which says let u to represent everything that is a function of x inside the bracket, which is 1 minus x squared. Let's call this equation I. Therefore, original problem now becomes that y equals to, instead of this, we now replace it to be u all raised to the power minus 1 over 2. That becomes equation II. Now we are going to differentiate both equation I and II with respect to x. Coming to equation I, we have u, we have x. We now differentiate u with respect to x. Differentiating u with respect to x will give us du dx. So we now have that du dx will be equals to, differentiate 1 is a constant, is 0. Differentiate minus x squared will give us minus 2x. How did we do that? Look at it. When we have minus x squared, the power is 2, the coefficient is minus 1, invisible 1 is here. So for us to differentiate, you multiply the power by the coefficient. After that, you subtract the power by 1. Can we do that? Now let's do that. 2 times minus 1 will give us minus 2. Then x to the power 2 as it is. Subtract the power by 1, minus 1. So we now have that minus 2 x to the power 2 minus 1 will give us 1. So that becomes minus 2 x to the power 1 will still have to give us x. So that is how, if we differentiate minus x squared, we have minus 2x. Please take note. Okay, so this becomes equation III. Remember, this is our rough work. This is our rough work. We are trying to get the second derivative of this function. That's exactly what we are doing. Okay. Now, next is to differentiate equation II. Equation II, we have y, we have u. We don't have to differentiate y with respect to u. If we differentiate y with respect to u, we are going to have dy du. So we now have dy du is going to be, of course, the coefficient here is invisible 1. The power is minus half. So if we differentiate, we're going to have this to be, of course, we have u to the power minus 1 over 2, and the coefficient is indivisible 1. Half times 1 will give us half. Then u to the power minus 1 over 2 as it is. Subtract the power by 1 minus 1. So if we simplify further, we're not going to have this to be, of course, the power here is minus 1 over 2 minus 1, which is the same thing as minus 1 over 2 minus 1 is same thing as 1 over 1. So what is the LCM of 2 and the 1? LCM of 2 and 1 is said to be 2. 2 into 2 will give us 1. 1 times minus 1 will give us minus 1. Then this minus is this. 1 into 2 will give us 2. 2 times 1, 2. So I'm going to have this to be minus 1 minus 2 will give us minus 3 all upon 2. So therefore, this is going to give us minus half, then u to power minus 3 over 2. Therefore, if we differentiate y with respect to u, we are going to have 1 over 2 minus 1 over 2 minus 1 over 2, then u to power minus 3 over 2. So let's call this equation IV.